All right, guys, 8.1, we just talked about, hey, series and sequences. What are they? How do we write them? How do we calculate them? Now in 8.2, we're going to just dive into arithmetic sequences. All right, so in 8.1, we talked about what arithmetic was, how to recognize one, how to write an equation for one. And then today we're going to dive just a little bit deeper. And then next class, which will be on Wednesday, we'll dive a little bit more into geometric. Okay, I will warn you, I do have some errors on this. If you notice right at the top, it says 8.2 on yours, doesn't it? But then it says define something. If you want to change the title to analyzing arithmetic sequence series, go for it. If it doesn't bother you, don't worry about it. Okay, so our objectives today: identify arithmetic sequences, which we've already done. We're going to write rules for arithmetic sequences, which we've already done, but now I'm going to give you guys a formula for it. And then we're going to find sums of finite arithmetic series. Okay, so what is an arithmetic sequence? Well, we've already talked about it, but by definition, the difference of consecutive terms is constant. I might call that the slope, based upon when we graph arithmetic series and sequences, they are linear, so I might call that the slope. Okay, so example 1, it says tell whether each sequence is arithmetic. Well, we know that if I'm trying to determine if it's arithmetic, I better have constant change. So here I'm going up 7, up 7, up 7, up 7. Is that arithmetic? Yes, it is. Constant change. Here I went down 8, and then I went down 6, down 4, down 3. Is that constant? No. No, it is not. Okay, pretty easy. Again, we did that last class. All right, now writing rules for arithmetic sequence. We've already done this. We did it on our quiz. We did it on our bell ringer, and I always use the, find the slope and then go back one. Now you guys can use that if you want. I think that's a pretty darn good way, but here is a formula if that doesn't help you. So if you don't like the way that I've taught it, well, you can use this formula. So here it goes. It says the nth term of an arithmetic sequence with the first term a sub 1. Okay, so the first term in the sequence is a sub 1 and a common difference d. Okay, so in the formula we have an a sub 1 and a d. So a sub n, any term in this sequence, can be defined as a sub 1 plus n minus 1 times d, which is our common difference. Okay, so a sub n is just any particular term in the sequence. So a sub 1 is the first term in the sequence, and then d is our common difference. All right, and will always be in our rule. Okay, you think about the one we did over there. There's always going to be an n or an I or a k to represent our unknown. So, and I think the directions here are wrong, but basically we're going to take this. We're going to ignore those directions. We're going to write a rule. Okay, so we're going to write a rule. And if I look here, this is a sub 1. Actually, both of these are wrong. Do you guys notice that? So let's correct those now. Change those. I forgot to change those from the other one. So those on your example 1 are wrong. So you just cross those off and write what I have up here, please. Okay, so this is the first term in the sequence, second term, third term, fourth term. So this value right here, 55, is what we call a sub 1. It's the first term in the sequence. Okay, now we want to write a rule for this. Now, could we use the way that I've always done it, or that I've taught you? Absolutely. But the thing about it is we're going to be using this formula to do other things, so the more comfortable we get using this formula, the better off we'll be. Okay, so let's write that down. It's a sub, our formula is a sub n equals a sub 1 plus n minus 1 times d, which is our common difference. Okay, so if I want to write a rule, well, if I look here, n is always going to be in the function, and a sub n is always going to be in our function, but we need to replace a sub 1 and we need to replace d. Do I know the first term in my sequence? 55. It's 55. So in goes 55 there. Do I know our common difference? Well, how much are we changing by? It's 8, and we're going down by 8, right? So that's going to be important. Are we going up 8 or down 8? Will depend if it's 8 or negative 8. So in this case, it is negative 8. So I'm going to have n minus 1 times negative 8. Took our formula, plugged in a sub 1, which is the first term in our sequence, plugged in d, which is our common difference, and now we can solve for that thing. All right, now, to solve for this, I need to distribute the negative 8 that way. So I get a sub n equals 55. When I distribute negative 8 to n, well, that's going to give me minus 8n, or you could have maybe a plus a negative here. And then negative 8 times negative 1 is positive 8. Okay, so then I can combine like terms. I'm going to put my n first. I always put my n's first, so negative 8n, or I should say just put my variable first, and then 55 and 8, isn't that 63? Yeah. 63. Okay, if you would have used my shortcut like we did up here and worked backwards and found the 0 term and added 8, we would have gotten 63 here, wouldn't we? So we would have gotten the same answer. Maybe you like that way better, but like I said before, in the next couple of problems, we'll be doing some more things with this formula, so the more we get used to it, the better.
So that would be our 8.
Negative 8n plus 63, that is our function rule, our sequence rule for define any term in the sequence.
So like it would be that 1 versus k squared.
Yes, yep. Okay, same thing here. Let's first check if it's arithmetic. I'm going up 5, up 5, up 5. I am, so that's good. So my function here is going to be a sub n equals a sub 1 plus n minus 1 times the common difference, which is d. We need to plug in the first term in the sequence, which is 3. And our common difference, which is 5. And then we can simplify from there. I'm going to distribute my 5. So here I'm going to get 3 plus 5n minus 5. And then a sub n is going to equal 5n minus 2. Questions there? Okay, example 3. It says one term of an arithmetic sequence is a sub 19 equals negative 45. That means the 19th term in this sequence is negative 45. Okay? It also says that the common difference is negative 3. Write a rule for the nth term. We're going to stop there for now. We'll do the next part in a second, but we're going to focus on that part. Now, they gave us some information. They gave us some different information, all right, but we're still going to go back to our equation or our formula. So we've got a sub n equals a sub 1 plus n minus 1 times the common difference d. Okay, so in order to have this equation, if I go back up here, we need to have our first term in our sequence. Do I have my first term in my sequence? No, the only term that we have is the 19th one. Okay, so I'm going to plug this and this into the function. Where does negative 45 go? I like n is 19, and so maybe I should erase that and just put 19 in. I agree, n is going to be 19. The 19th term in the sequence is negative 45. So what's this then? Absolutely. I'm going to put negative 45 over there. Do I know what a sub 1 is?
No.
I don't, do I? That's what we're solving for. What is n? 19. So I'm going to do 19 minus 1, and our common difference is negative 3. So we're still using that formula that we have, that equation, but now we just have different things. So order of operations says we should do parentheses first, so that gets me 18. So I get negative 45 equals a sub 1 plus, this gets me 18 and negative 3. What's 18 times negative 3? What do we get? Negative 54. So a sub 1 minus 54. And then to solve for a sub 1, I'm going to add 54 on both sides. 54. And we get 9 equals a sub 1. So by given some information of this sequence, we're able to find the first term in the sequence. Okay? Now, understand what our goal is. It says write a rule for the nth term. It doesn't say find a sub 1, it says write a rule. Now, part of that is we have to find a sub 1 first. But our rule should be a sub n. Again, I'm going back to this formula. I'm going to plug a sub 1 in there, so that's going to be 9 plus n minus 1, and my common difference is negative 3. We're going to distribute my negative 3. So a sub n equals 9. Negative 3 times n, that's going to give me negative 3n. Negative 3 times negative 1 is positive 3. Combine like terms there, and a sub n equals negative 3n plus 12. Are there questions about this problem at all? Same formula, just plugging into some different things, solving for just a different part of it. Now, the second part says, then graph the first 6 terms of the sequence. Well, if I plug in 1, the first term of the sequence, if I plug 1 in for n, what does that give me? 9. So at 1, I'm up here at 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 9 is on the graph. The second term, if I plug in 2, what do we get? 6. So at 2, 1, 2, 3, 4, 5, 6. Okay, now, if it's arithmetic, guys, I've said this before, it's linear. Watch me, watch this. If it's linear and I got the first point in the right spot, well, I know I can go, my slope is negative 3. So from here I can go down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1. Rather than plugging all those in, if I wanted to just plot those, you can do it that way. It's not a bad idea maybe just to plug in, let's just say, 4 and just check it. If I plug in 4, I should get 0. Do I get 0? Yeah. I do, it works. Should I connect those with a line?
Yes. You don't have to?
The answer is no. Okay? Because watch this. If I connect this with a line, that means all of the points between, let's just say in this example, 4 and 5 are in my sequence. Is 4.5 in my domain?
No.
No, it just goes from 4 to 5, okay? So when it's a sequence like this, we don't want to connect them. We're just plotting those whole numbers. Questions about that? Okay? Guys, I'm just forewarning you. On our homework, there's literally problems like the first example, problems like the second example, problems like this example. There's literally problems that model every single example we're doing. Okay? This one gets a little bit different. It says 2 terms of an arithmetic sequence are a sub 7 equals 17 and a sub 16 a sub 26 equals 93. Find the rule for the nth term. So it doesn't give us a sub 1, which is the first term in our sequence, and it doesn't give us d, the common difference, does it? So this one's unique in the fact that we don't have two things. Well, I'm gonna focus on just this for right now and plug in what we know. So my formula is a sub n equals a sub 1 plus n minus 1 times d, my common difference. So what do I plug 17 in for again? A sub n, so 17 equals, I don't know what a sub 1 is, do I? No. Do I know what n is?
Yeah, 7.
It's 7, so 7 minus 1. Do I know what my common difference is? I do not. So that's really all I know. Now I can simplify that. This is going to give me 6, so I'm going to get 17 equals a sub 1 plus 7d.
Wait, 6.
Ooh, 6, thank you. 6d. Okay, we're going to do the exact same thing with our other info. A sub 26 equals 93. So I'm going to plug in 93 here equals a sub 1, which I don't know, plus n. In this case, n is 26 minus 1 times my common difference, which is d. So 93 equals a sub 1 plus 25d. I'm still missing two things though, aren't I, guys? I'm missing a sub 1 and I'm missing d, my common difference. Now, would you guys agree with me that in this equation and in this equation, a sub 1 is going to be the same thing? And in this equation and that equation, d is going to be the same thing. Okay? Guys, remember when we talk about systems of equations? In solving systems. So if we don't have two unknowns, we better have two equations to solve those unknowns. If we have two equations, we can find them. Okay? So what I'm going to do is I'm going to take this equation right up here. 17 equals a sub 1 plus 6d. I'm going to use this equation. 93 equals a sub 1 plus 25d. And what I'm going to do is I want to try to eliminate a variable. So if I subtract them right now, what's going to happen to a sub 1? It's going to go away, isn't it? And that will help me find d, because if I get rid of one variable, now I only have one left. So help me out here. 17 minus 93. Negative 76 equals, those go away. Guys, let me back up here just briefly when I talk about this. Guys, when you subtract a lot of things, what do you need to do? You should probably make everything negative all the way across, just to, I think I heard negative 19, which is the right answer, but I can easily see someone saying 31 because you see the at. So distribute that negative throughout, and this gets me negative 19d, right? How do I solve for d? Divide by negative 19, and so d equals 4. Okay? Now, there's basically step 1. We found d. But when we write a rule, we need a sub 1, don't we?
Yep.
We have to have our first term in the sequence. So what we need to do is we need to pick one of these, either one. And when we solve a systems, don't we have to go plug that back in?
Yep.
Absolutely. So we need to just pick this equation or that equation and plug it back in. So if I pick this guy right here, I'll do 17 equals a sub 1. Actually, I'm going to go up here. 17 plus, equals a sub 1 plus 6, and I know what d is. It's 24. Ooh, I'm ahead of myself. 4. Now I have everything except a sub 1. So here I'm going to get 24. So 17 equals a sub 1 plus 24. Minus 24 on both sides. A sub 1 equals negative 7. So now when I'm writing my rule, a sub n equals, I have my first term, don't I? So that's negative 7 plus n minus 1 times my common difference. What's my common difference? 4. Distribute my 4. So a sub n equals negative 7 plus 4n minus 4. And combine like terms, a sub n is going to equal 4n minus 11. Questions there? So there's kind of 3 steps there. Okay, this one's our most complex version. But again, guys, when it comes to problems that are exactly like this on the homework, what are we going to have in front of us? That, hopefully. Okay, plug in what we know, set up a system of equations, solve for our common difference, plug it in, find our rule. Okay, last thing I want to talk about is summations of finite arithmetic series. Okay, so we have a formula for this. So the sum, which we're going to have represented, I'm just going to have to roll with it, I think. S sub n goes there, guys. S. Give me 1 second. S sub n goes there. Here's our formula. The sum equals n times a sub 1, which is the first number in our series, plus a sub n, which is the last term in our series, divided by 2.
What was the first part?
Let me go back all the way, Cole, because my thing, it says the sum, which is S sub n, so we're finding the sum, of the first n terms. So if I want to find the first 7 terms, 7 is n, okay, in an arithmetic series. So in this case, n represents the number of terms that we're finding, okay, the first 7 terms, the first 23 terms, whatever that is. A sub 1 is the first term in the series. A sub n is the last term of the series. Okay, so in order to find the sum, we need 3 things. We need the number of terms that we're finding, that's n, the first term of the series, and the last term of the series.
What is that written as? It's S.
Like that. S sub n. Just the sum of n numbers. Does that make sense? The sum of 4 numbers, 12 numbers, whatever it may be. Okay, so here we go. It says find the sum of each series. Okay, so it's arithmetic. So S sub 20. Okay, I guess before we do that, we need a couple things. We need the first term in the series. We need a sub 1. So I better plug in 1 into my sequence, or I guess the sequence. Plug in 1. 3 times 1 is 3 plus 7 is 10. I then better plug in my upper limit, which is 20. I need to find a sub 20. I need to find the last term of my series. So if I plug in 20 there, 3 times 20 is 60, plus 7 is 67. Questions there? Okay, so my formula is n times a sub 1 plus a sub n over 2. Well, n is how many here?
20.
Yeah, that number right there is n. It's going to be 20. The first term in my sequence is 10. The last term in the sequence is 67. I'm going to divide that by 2. So S sub 20, the sum of the first 20 terms of this series is that right there. We can do math. 10 plus 67 is 77. 77 divided by 2, whatever that is, times that by 20. 770. Okay, so rather than finding all of them, okay, like maybe we've had to do in the past, and just write them all out like we did in our homework over in our bell ringer, well, now we have a formula if it's arithmetic. It only works if it's arithmetic.
Is there a geometric one?
There is, and we'll do that on Wednesday. Okay, last one here. Why don't you do this on your own? Find a sub 1, find a sub 18 in this case. Okay, so a sub 1, what do we get there? That's 2, right? A sub 18 is negative 66. So our formula, S sub 18, the sum of the first 18 terms of this sequence is n, which is 18, times 2 minus 66. Guys, if this is negative, that needs to be negative. All divided by 2. So here I think this gets me, let's see, negative 64, right?
Yep.
Divided by 2, negative 32, times 18, negative 576.